Hello folks, if you ever tried deploying machine learning applications in production, you may understand that a great deal of effort actually goes into the provisioning of resources or the infrastructure that your application needs. It could be the compute environment like a Kubernetes orchestrator or a VM, or it could be tools that your apps needs, for example, model deployer like Kserve or Seldon. So on top of setting up these resources, you also have to make sure that you have configured these in the right way so that they can talk to each other and work as you want them to. Now we at ZenML understand the pain that comes along with it, and we have a solution for you in the form of stack recipes. So in this video, I'll introduce to you what stack recipes are, how you can get started with them, and how you can use a stack recipe to go from scratch to a full-featured MLOps stack with just 2 commands. Stay tuned. Alright, so first I'll start with an introduction to a short description to what stack recipes actually are. So stack recipes are a set of carefully crafted Terraform modules that when you execute can set up this MLOps stack for you. This stack can have multiple components that ZenML supports like orchestrators, model deployers, step operators, artifact stores, and anything you wish to. And each of these components have multiple configurable parameters, so you can change their names, of course, and you can also have component specific settings like maybe changing the IP addresses allowed for ingress, all of that stuff. So enough of the talking, now let me jump into a repository that we have which hosts all of these recipes and also has some instructions for you to get started with deploying a recipe. Alright, so this is the MLOps Stack repository under the ZenML organization, and if you scroll down to the README section, you can see there's a list of recipes available at this point. And each of these recipes also have components listed, so whatever tools you get when you install this particular recipe. So you have Kubeflow, you have MLflow tracking, you have Kserve, and also some cloud specific tools like S3, RDS. And so this is the entire list of recipes that you have, and you're not restricted by that either. So we'll touch on that later on when we talk about extending recipes. But this is the list of recipes you can currently deploy. And how do you do that? You can scroll down to this section with ZenML stack commands. So you have this new ZenML stack recipe CLI commands that you can use to list, to pull, and then to deploy a recipe. So that is in short how exactly a recipe works. You can also use Terraform directly instead of the ZenML CLI if you want, but that strips you off a lot of important log messages and some other help in the form of checking your system configuration and stuff like that. So that is the idea, and this is the video which actually talks about extending your own recipe, so we'll be touching on that later on as well. So don't worry about it. Okay, so now enough of this repository. Now let's switch to an example, a ZenML example that I have, and then we'll see how we can use stack recipes to actually go about deploying the ZenML pipeline. So this is the case of deployment example, and you can find it inside the ZenML repository under the examples directory. And it has 2 different pipelines, a PyTorch pipeline and a TensorFlow pipeline. We'll be running either of these in this example. And as the name suggests, it also uses Kserve as a model deployer. So we understand that we need a recipe that actually has this component. So how do we actually figure out what recipes we have available? We can either go to the repository or we can use the ZenML stack recipe CLI command to actually list all available recipes. So the list command here pulls all the information from the repository onto your terminal. Okay, so this is the list of recipes that are part of the repository at this moment. So we can see there's a GCP Kubeflow Kserve recipe. I think this is relevant in our case since we need Kserve. So I'll just try to pull this recipe locally. So I'll do a ZenML stack recipe pull, and the Y flag can be used to pull the latest changes. So I'll just use that. And then I'll specify the name of my recipe that I need. So this is GCP Kubeflow Kserve. So when I execute the pull command, it's going to pull the latest version of this recipe to my local system. Alright, so it's now pulled, and you can see there's a new folder that comes up, which is ZenML stack recipes, and it has a subdirectory which is by the name of the particular recipe, so GCP Kubeflow Kserve, and then it has this entire recipe files here. So what I can do here is, first of all, let me go into the locals file. So the locals file is a way to configure different components. As I already mentioned, we can also have component specific settings that you can modify. So this is the file that you use to do that. So you can change the project ID for GCP. So maybe I'll do that, and I'll set maybe a new project I created some time back. So I think that is a good enough demonstration of it. And you can add a prefix. So prefix is something that gets attached to the name of all the components that you create. So you can change the prefix, you can change the region, and then you can go into component specific settings as well, as I told you, GKE or VPC settings. So I'm not going to modify any of these here because I think the defaults are also nice. So you have to understand that most of these defaults are same defaults, and you can just proceed without changing any of these. So it's designed in that way. But you can also feel free to change anything you want, as well as change anything in the respective files as well. So if you have some knowledge of Terraform, feel free to again modify any of these files as well if you want to achieve something different. But we'll talk about extending later on as well. All right, so I have modified the locals file here. So this allows me to customize this recipe to my specific thing. I also need to have Terraform installed, as well as Helm. Helm is used for deploying applications on Kubernetes. I need to have the gcloud CLI authenticated with my account on this project itself. All right, so once all of these things are ready, then we can go ahead with deploying this recipe here. So I'll just close this for now. I'll open my terminal again, and let's do a ZenML stack recipe deploy, and then the name of the recipe which I just pulled. Right? Okay. Now with this command, there's also flags like -- import. What this -- import flag does is, after this recipe is deployed, it automatically creates a ZenML stack for you with all the components that were part of this recipe. So how cool is that? So first of all, when you run deploy, you also have a preview of the locals file again. So you can take a look at all the components here and just verify that these are indeed the values you want your application to have. Once you're done with that, it gives you a prompt to actually confirm if you want to go ahead with the deployment. I'll just say yes. Yeah, now it started initializing the modules and all of that stuff. Alright, so now it has a list of components that is going to deploy for you, and you can just look at those and then decide if you want to execute or not. I'll just say yes. So the second prompt which comes in is from Terraform, and the first one which came was from the ZenML stack recipe CLI commands. So after you do yes, and then it'll start executing the recipe and then creating all those components for you. And you can see all those in action in this logs here. It usually takes around 10 to 15 minutes, and it also depends on the kind of cloud you're using and how fast that is. But you should be able to look at all the progress right on the logs here. All right, so now it has this list of resources that it will create for you, and then you can review them, and then if you want, you can start with the execution of these things. All right, so it says the recipe deployment failed, and I think there's an envoy filter CRD which is missing. That's strange. But this is a known limitation of any recipe that uses Kserve at this point. So in order to make this go away, you just have to run the recipe again. So that's what I'm going to do right now. I'll just deploy the recipe again. It will go through the entire process of checking with the local file, and then when I do UI, it says Terraform already initialized, so it's not going to do Terraform init again. So that's part of the recipe deployment. It figures out that the required definition and provider is already there, so it just goes straight to the apply section. This will again give you a list of the resources that are still left to be deployed, and when you click on yes, or when you type yes, it will resume from where it left off. So you don't have to worry about duplicate creation of resources that way. Alright, so the stack recipe got deployed, and that is indicated by the presence of these outputs at the end of the execution. So you can see there's a whole list of output of the resources that are deployed as part of the recipe execution. And there's also a very interesting output called stack YAML path, and which gives you a path of a file. And this file essentially is the stack YAML configuration. So when you go into this file, you will find definitions for all of your stack components that you can just import directly. And you remember I mentioned there's also -- import flag that comes to deploy. So that flag actually takes this file and automatically creates a stack for you. So you don't have to do it manually. But I'm doing it manually just because we'll go into this file and then observe what different components there are. Alright, so let's first, the benefit actually, one more point, the benefit to having such a stack YAML file is that you don't have to take all of these values individually and copy paste them into the definition of different components while registering as an ML stack. So all of that is already pre-filled for you. If you go into this directory where your recipe is pulled, you can see there's this new file which is created by the name of GCP Kubeflow Stack. Now let's observe this file for a bit. It has multiple components like the artifact store, container registry, metadata store, and each of these components have some specific attributes. Like the artifact store has an attribute called path, and this path is a path to the bucket which gets created for you after the recipe is deployed. And now if you scroll further, you can see even stuff like host and something like username and password for MLflow. So this also deploys the authenticated MLflow server with this username and this password, and you can access it at this particular URL. Alright, so you can also observe one other thing, which is the secret component. So you have some secrets already defined for each stack component. And now you have to keep in mind that you have to create these secrets with ZenML before you can actually run any pipeline using this stack. And because secrets are not created by default as part of the recipe execution, because they require an active secret manager stack component. So you have to first import this stack component, so import this YAML file into a stack, set this as an active stack, and then you have to create the secrets. We'll be going over that process right now. Okay, so let me first start with importing this YAML file as a ZenML stack. So what I'll do is do ZenML stack import, and then specify the name of the stack I want. For example, let's say demo stack, and then the path to this YAML file. And also I'll just change this value to 0.13 because this is the version of ZenML I'm using at this point. I'll copy the path and then I'll just paste the path here. I have to modify some values here because I'm on WSL, so that needs to be done. Alright, now let's see what happens. You also need to have some integrations installed on your system that correspond to each of these components. For example, you need to have MLflow installed because that is also a part of this stack. You also need to have Kserve integration installed. So you have to make sure whatever integrations there are involved with this stack YAML file, you also have those installed. Otherwise, it will also give you a prompt as an error to also install those things. So don't worry about that. So it's now registering all of these components, and these are the names and these are the versions. So you can see it registered the stack successfully, and now we can set this stack as an active stack. So I'll do ZenML stack set demo stack. So this should set it as an active stack, and now I can start creating secrets for my stack components. Alright, so now I'll go over to the README file for the particular example, and that will give me some commands which allow me to create secrets for it. So I'll just copy the command which is used to create a MySQL secret. So here it is. So it has multiple fields. So let's just figure out what are the different values we need to actually be able to create the secret. So we need a SSL key, we need a certificate, we need a password, username. So all of these values need to be provided to this secret. So how do you get those values? So let me first start with maybe showing you how exactly those values are obtained. So username and password are part of the deployment of this recipe. So all of those values are covered by it, but certificates you'll have to install from the Cloud Console portal itself. In the future, in the updates to this recipe, I'll also add these certificates as part of this recipe output. But for now, we'll have to go to the Cloud Console to download these certificates. So first of all, let's just first get the username and the password. So for that, I'll go into this particular stack recipe directory. So I'll have to first cd into ZenML stack recipes / let's say this one. Alright, so once you're in this directory, now you can do Terraform output. This will give you a list of all the outputs that you have that you can obtain the value for. So these are the outputs, and now you can see there's a password and a username, and both of these are sensitive values. So what I'll do is I'll just copy this key here, and then I do Terraform output, and then specify the name of this key. So this is now going to show me the sensitive output right here. So this is the output, which is the admin. So admin. So this is the username, which is admin. So we'll just keep track of that. And now I'll do the same for the password here. So let me just paste this command, and this will show me the password that I need for this particular thing. And this will show me the password that I need for my MySQL instance. Alright, so we have the username and the password now, and now let's go to the Cloud Console to actually get the certificates. So open up a new page with the Google Cloud Console, and I'll make sure I'm in the right project. So I'll switch to ZenML Vertex 1 because that was the project I was actually deploying the project, deploying the resources to. So I'll go into CloudSQL or just SQL, I think. Yeah, SQL. So this will have my newly created instance, which is the demo ZenML Kubeflow, and this name is actually derived from the locals file that we defined earlier. So we have this demo prefix there, and that is why I can identify this is my particular file. If you have multiple people working in a team using the same account, you can differentiate between your instances by using this prefix, which I showed you earlier. Now, when I want to get the certificates, I'll go into the connections tab here. I'll go into security, and then I'll create a client certificate, right? So that is how I'll do it. So maybe I'll do a test name, and then I do create. So this should create a series of certificates that I need. Exactly. So these are the 3 secrets that we needed in the secret. So I'll just download these files here. So I'll quickly download all of these files first of all. Alright, so behind the scenes, I'll already transfer the 3 downloaded files into this directory. So it's now under the case deployment example directory. So you can see those 3 files here. And now let me first go into this directory, and now I can just run the command that we had earlier, and it'll be easy for us to run those. So maybe I'll just copy it again, And yeah, let's paste it here. Now replace these placeholders with the exact file name. So I'll do that right now. And for the password and the username, it's same as what we saw earlier. So I'll just use a clipboard here to go back. This is the password. And for the username, I remember it was admin. So I'll just put that value here, admin. And now let's run this. So this will create a new secret with ZenML and by the name of MySQL, GCP MySQL secret. And we also verify if this is the same secret name as the one which is present here. So that needs to be the same, otherwise it will not be able to associate that with this component. So it's now saving a secret with that name. So it will register a secret on the GCP secrets manager and done. So we now have a secret by the name of GCP MySQL secret. The other thing that we need to do here is set up the GCP Kserve secret. Now for this as well, I'll go back into the documentation on the README. I'll copy the command from there. There it is. So this secret requires us to supply some kind of a credential file. And thankfully, we don't have to go back to the Cloud Console for that because this recipe already created a JSON key for you. Essentially, this secret allows Kserve to access your cloud storage. And this key corresponds to a service account that this recipe created, which has access to the cloud storage, basically. So what I'll do is I'll just replace the value here from the example to my key name. So it should be SA service account key.json. And now this should be sufficient for creating it. Let us first also verify if the name of the secret is same or not. So this is called GCP Kserve secret, but here is still only Kserve secret. So I'll just modify quickly the name of the secret. So it should be GCP Kserve secret, and then everything else is just same. So I'll just press enter here and wait for ZenML to register this secret with the GCP secrets manager. Alright, so it's also registered. So now we are ready to actually run the pipeline and see it in action. Perfect. So what I'll do is I'll copy the command to run the TensorFlow pipeline from, again, the README, and I'll just paste it here. So this is the command which runs the TensorFlow pipeline, and then I'm just going to hit enter and see what happens next. And we expect the TensorFlow pipeline to run on the Kubeflow orchestrator, because if you look at the file here, it says the orchestrator is Kubeflow. Right, so that is what we expect it to run on. All right. Oh, it first says that I need to do ZenML stack up. So this will set up port forwarding between the Kubeflow pipelines and my local system. So this will allow me to connect to the Kubeflow pipelines dashboard to see my pipeline in action. So we need to first run this command and then the run command after that. All right, so it is now active at localhost 8080. So we'll be able to look at our runs at this particular link. So first, let me just submit the run again. So using this command, I'll just start the pipeline, and once it is deployed to Kubeflow, we'll go into the UI to actually see it in action there. Alright, so it has now built and pushed a Docker image which contains all of the code and the pipeline definition, and it's now going to create a run on our Kubeflow component. So you can see it's already started a one-off pipeline run. So let me just pull out the browser window with localhost 8080 here, and we can then observe how our pipeline is doing. So you can see the first step is already there, and the pod is in the initializing state. If you go into the logs section, you can also look at the logs once the pod gets active. So this is the first step, and maybe I'll just refresh this page a bit, and yeah, there it is. So it's now active, and if everything is right with our stack, if all the configuration settings are right, then we should expect that this entire pipeline completes without any failures. So that's what you're looking for. So let's just fast forward to the end where there's a Kserve step, and we'll then verify if our Kserve step worked as well or not. Alright, so here's the Kserve step, and if you look at the logs, you can see there's a predict URL which gets active, so we can verify that this pipeline actually worked. And even if you look at this entire flowchart, you'll see all of the steps are green, which is a really nice signal. And that's it. So now once you run the pipeline, all you need to do is do a ZenML stack recipe destroy, and the name of the recipe that will destroy all the resources in the Google Cloud that related to this particular recipe. You can also do a ZenML recipe clean to delete all the files related to the recipe that you downloaded to your local system. So that's it. Stack recipes in a nutshell. They allow you to go from scratch to a full-featured MLOps stack, and you can even run advanced pipelines like the one we did today with Kserve on Kubeflow pipelines very easily. Give us a star on the repo if you like this demo, and we're looking forward to your contributions. Thank you for watching this video.